Write the following in equivalent logarithmic form. So to change something from exponential form into logarithmic form, we use the same mapping as going from logarithmic to exponential. So the mapping is this. If I have y equals log base b of x, and I call that my log form, then the equivalent exponential form would look like this. We would have a base of b, and the base is the easiest term to identify because it's the subscripted value on the logarithm. The result of the logarithm is an exponent, so this is b to the y value, and that's equal to the argument of the logarithm. So this gives me sort of a mapping to change between exponential and logarithmic form. And this is a really important concept to be able to do effectively because it helps you later on in solving equations. So to go from exponential form into logarithmic form, first off, for part A, I have 3 to the 4th equals 81. So the easy value to identify is the base, because the base of your logarithm and the base of your exponential are generally very easy to identify. All right, so it's a log base 3, but then what goes next? Well, if you just remember that the result of a logarithm is an exponent, then that tells you exactly what to do next. So the result of the logarithm is an exponent. So the 4 is going to go over on the other side of the equals, leaving the 81 to be the argument. Next we have 2 to the 5th equals 32. And again, the easiest thing to identify is the base of the logarithm. So we'll just write log base 2 to get us started. And the result of a logarithm is an exponent. So the exponent of 5 goes on the other side of the logarithm, the equations. And then the argument is the remaining value, the 32. For part C, things are looking like it's going to get a lot more difficult. Because here we've got negative exponents, we've got fractions. But as long as you follow this mapping, it's not really any more difficult to do this one. So the base of your logarithm is still the number that has the exponent attached to it. So in this case, our base is 2/3. So I'll write log base 2/3, and I tried to make that as subscripted as possible. The result of the logarithm is the exponent. So that means this number here, 27/8, becomes the argument of our logarithm, and then that's equal to the exponent, which is -3. So this is the equivalent logarithmic form. Then in part D, where I have 10 to the -4th power equals 0.0001, just follow the same mapping. So it's a log base 10, so log base 10, and the result of the logarithm is the exponent, so the argument is this number here, 0.0001, and the result there is the exponent, -4. Now, because this is a log base 10, a common logarithm that is, you don't actually have to write in the base. It's just understood to be 10 if you omit the base, so you could express it this way as well.